Hello and welcome to a little video on how to run a Hadoop cloud. This can actually work with anything, but I'm just showing you how to do it on VMware. So this is VM Workstation running on a Windows workstation. And as you can see, I have 5 Ubuntu Linux VMs running. So UN00 to UN. So they all have Hadoop installed, Java installed, and everything. But one of the important things happens to be is how to get the entire environment set up the way you want it to in this on a Windows workstation. So what I've decided to do is make a private network on VMware and have all the VMs work only with the host in that regard. So as you can see, all have IP addresses and host names. From the IP addresses start around 200 with host names of UN00 with localhadoop.com in them. It goes the same for UN01, UN02, UN03, and UN04. So they're all the same, other than their IP addresses. Um, so this is accomplished in a couple of ways. It has to be first set up in VMware, Windows. So let's start off with VMware, since that's where we have to ensure everything is set up for the virtual networking. And that's actually established with a VMware network, virtual network called 5, host only. And you can see that I have it connected through this adapter. It's using its own DHP service for the IP addresses, and this is the range of where it's, the IP subnet and the subnet masks. If I look at the DHCP settings, you'll see the range, starting IP address and ending IP address, and so forth. Once I have this virtual network set up, I need to actually make a similar tie to it to my Windows hosts. And that's mainly because, again, my guests are really only going to be connecting or understanding what's going on the host, since it's a private network. So what you really want to do next is go to, on your Windows machine, go to your C drive, Windows, System 32, drivers, etc., and find your hosts file. That hosts file would look something like this. It's very short, doesn't have a whole lot. Most of it will be commented out, and add in the IP ranges from your VMware virtual network and mapping those to your host names on your Linux guests. This has the benefit of ensuring that they all see each other, and it also has the major benefit of when you start up your VMs, you may for whatever reason start them up in the wrong order, different sequence. They will always have the appropriate IP addresses. So this is how that works out. On the VMs themselves, what you'll see is their host names and their IP addresses are obviously there, but that requires basically modifying the hosts file, and I'll just simply cat those out, to include the host name for your existing machine and the IP addresses for your future machines and the actual host name. So these are virtually identical on every machine. And this is what ensures that everything is working together between all the various VMs. A good note here is, since it is a host-only network, it is not going out to the internet, so I'm not going to be updating these VMs or anything else. So it's all going to stay on my local machine and not saturate the network. So now that everything is started, let's go ahead and start up Hadoop. And the way that I have my current VM set up is that the UN00 is the master node or the master name node, and everybody else is a data node and task node. So we'll start that up. And we'll log in. I've already logged in onto the Hadoop side. So what I'm going to do is go to my directory and execute the startup scripts and start everything up. So what you can see now is that one shell script kicking off every servers. There are some configurations that have to go on to ensure that all works, and I'll kind of generally cover that in the next step. But now that everything is started, we'll kind of like see what has actually been constructed. So we'll just use JPS And you'll see a name node, data node. Secondary name node is on this system, job tracker, and a task tracker. On Hadoop, with Hadoop on the other machines, what we'll do is just do a simple JPS. There are data nodes and task trackers. Again, we'll just go through every one for the sake of completeness, but they'll all be data nodes and task trackers. All right. Now, one of the things to keep in mind is that part of the setup requires SSH connection to all of the machines inside the Hadoop cluster. And part of that I'm not going to go through the actual SSH setup, but essentially you have to set up the SSH and ensure that you SSH into set up a basic password for your SSH, or actually none, because you want no password, passwordless setup. So you just set up your SSH, generate it with no password, and then populate that key after you're ensuring that it works. You can log in like SSH to the local host and the host name, then populate that key across all of the other slave nodes, and then everything will work and connect without the password. If you don't do that, when you start up the connections, it will actually prompt you for a password for each and every area. So now you say, okay, well, it's started. Now JPS is the easiest way to validate everything, but you can obviously do, since it's just Java and it's a Linux and it's a Unix system, all you have to do is also look for certain things like name node, and you can see that it's actually been that they've actually been started. So more than one way to look at it. Now, admittedly, this is a desktop. I could bring the desktop components up and look at all the various CPU and performance statistics from the system monitoring site. But I'll just run it through the command line so that you can see it in that manner. So if we run top, it will show you how much CPU is running and so forth on an idle system. And what we'll do is we'll kind of run top on the other window that we have running. So that we can see everything that's working on every area. All right. So now you can see everything is running, what the top things are doing, and so forth. So let's take a look at an existing. Let's take a look at the URLs from the system, and what we'll actually. Well, let's not do it from Firefox, although I like Firefox. What we'll do is we'll open up a new Chrome window, and here we are. So in my particular case, I already have what I'm looking for in terms of the local Hadoop. So we'll go with the local name nodes, and we'll also go with the local job trackers. So as you can see from here, this is on my Windows workstation. It can work on the Linux side as well, but you can see that the cluster has been started. It's not very large. I'm not making it very big, and it has everything here. You can also take a look at the name node logs, and you can browse the file system. These are all the basic web directories. And you can also take a look at the jobs and live nodes and so forth from everything. Here, it'll show you every node. All of them are present. And in addition to each of the nodes, you'll also find that they have their various, prior job tracker histories and so forth. So everything from the node and cluster, it's actually operating and looking like a basic Hadoop cluster. If you want to make sure that certain things are working within Hadoop, which is just fine, we can go ahead and execute a command to get the version. And we'll just not do a CD first, but let's actually execute it. There. So now you can see that it's there and it gives you the Java versions. So what we'll do is we'll log into the local area, and we'll actually go ahead and run the version. And it will show you the version of Hadoop. So it shows you that it's Hadoop 1.4, subversion, etc. So it works out very well. Okay, so now that we have all this, you can see that it can do a lot of things here. It can, if we wanted to do it, we can do Hadoop. Uh, look at the file system in Hadoop. As a sample. And it's going to reach across the network and so forth. So um, I guess I should probably start at the top level as opposed to nowhere. But now, one of the things you could do with VMware now, the VM network editor, which I really didn't show you before, is you can set up how fast or slow it is. And one of the things that I've done is kind of tweaked around with it so that it's kind of a little different than your default. Feel free to make it faster or slower any way you want relative to what you're doing. So as you can see, Hadoop is running. It has everything that's necessary. And it's working just fine. So the cluster is up and running, and jobs are running, and so forth. Now let's kind of go back to a little set of the basic configurations. And what you can see inside the configurations are in the configuration files, there's quite a few, but most of them that have been changed are pretty simple. The core site, the Hadoop environment shell, the HDFS site, the MapReduce site, the slaves, and the masters. We'll take a look at some of the other systems. And you'll see something very similar, that the Hadoop environments have been changed and so forth, except that their slaves and masters have not. So the common ones are these other environmental variables. So we'll again take a look. And they're all very similar. So what you can see in this particular case is that the system has been established and configured such that all of them are in accordance to who's the name node and who's not. And this is more of an administration standpoint for clusters working. Without the proper configurations in the proper way, most of them are easily done. I mean, it's not. It will be the case that your cluster may exhibit some bugs or some issues, or may not even start. So you have to make sure you have this all planned out. So what we're going to do is look at the core site. And you'll notice that the core site is pretty straightforward. It allows you to create a temporary working directory and where the main node is, or name node. In this case, it's UN00. So as one would expect, the core site is probably not going to be too much different from anyone else, and it's not. The next one that we'll look over in terms of the configuration will be the Hadoop environment. And as you can see, it is here set up pretty basically. There's not really a whole lot of significant changes. Again, you don't really have to really modify these. A lot of these are all optional, but you can do what you want and feel comfortable with, keeping in mind that this is all on your workstation. So the more that you decide to work with the cluster, you're going to have to make decisions about how well it's going to behave under a virtual machine setup on a single workstation. Again, it depends on how beefy your workstation is, but you do have to have those considerations. And the next one will be the HDFS sites. And you can see that they are all pretty much the same. They'll have replication values, data directories, and so forth. We'll go to another one and take a look at that. And if we look at this particular case, we will take a look at the HDF site again. And you can see also that it has very similar setups. So now that everything is established that way, the next thing we want to look at will be things such as the MapReduce. And MapReduce is also all established, number of trackers, where things will go, etc. Again, um, just for the sake of comparison, there are again no significant differences. The vast majorities of these configurations are very similar. They should be pretty exact between the nodes. The main differences again occur on the name node. Specifically, in our case, it will be the masters and the slaves. So what you'll look at in this case is that a master file and the slaves file have been established regarding who is the name node, primary name node, the secondary name node, and the data nodes. Whereas on all the subordinate nodes, the slaves and masters are left as default, which is let's go to this one. As you can see, they're all the same in these cases. They will all default to uh, the local hosts. So basic Hadoop jobs can be executed in this manner. We'll go ahead and run one as a sample on this system, and we'll do the basics, which will be the basic Pi example, which we'll run Hadoop, the jar. Um, we will use the Hadoop example jar pi 10 for 1,000 as a sample. And there it goes. It'll run 10 maps with a sample of 1,000 per map. As you can see, it is beginning to execute on the system. We can take a look at top and see that things are now running, tasks, sleeping, and so forth. We can see the CPUs running and so forth. So everything is running in these cases. When we start seeing that if they are not getting there now, they will be getting there soon as the process continues. So the job is now started. If we actually go back to our web browser and we look at what's actually happening on our system, what we can see is that the job has started, and we can see it kind of running here accordingly to that with one reducer and 10 maps. And if we go back to our VMware section, you can see it also operating. An obvious question is, well, what does it look like on your, say, your host workstation? That's a good question. So what we're going to do is start the resource manager and take a look at the performance. So as the job is executing, and I'll kind of move this a bit, a job is executing, you can see that on this 8 CPU system performing pretty well, but a certain degree of time, a certain degree of is kind of going from no free to some free to little free, and the processing is continuing. So what you can see in this particular case is the CPUs are keeping up just fine. It's the memory constraints for the operating systems. So that's kind of normal, to be honest, in the sense of general operation. So, and we can see that the job is running, the data is being calculated, the heap is going according to plan. So what we'll do in this particular case is come back to the job, take a look at this little CPU tracker, and you can see again, so this is generally what's happening with this particular workstation. It's not a really big workstation, but it is able to keep up with the tasks, although a little slow. As you can see in this case, 134 seconds. So we'll just leave it right about there for now. So the obvious question comes as to, well, is this representative of a Hadoop cluster? The answer is yes and no. It is a Hadoop cluster. It is running a series of main nodes. It's running a distributed job. Um, as we can see from every section on the web and the command lines, if we wanted to go look at logs, we'll see the same thing. The jobs are executing. We are able to take a look at the individual sections to see what's going on with all the processing. Um, but it is not the same in terms of a true representative hardware cluster in the sense that obviously it's virtualized, but even so that it's virtualized, it's really only just using all the resources of one machine, whereas in a normal cluster, you would actually be using most of the resources directly. Most people, again, as per standard, would prefer to run the VMs either very minimally or running the Hadoop software directly against the hardware. Um, and it does bring a level of understanding and appreciation to the operational side of Hadoop, which actually can help in the programming of MapReduce jobs and exploring other utilities. For example, writing MapReduce in Java is not the only ability or function within the Hadoop cluster. You can actually execute Hive. You can use Pig. You can digest information with Flume and so forth. There are a lot of different capabilities that may or may not be used in your shop currently. Um, and you may want to gain some much. Let's say that you're just beginning to understand MapReduce and Hadoop and the world of big data. You really just want to generally look at this and get a general understanding, and from there, uh, use it as a springboard into more complex and more advanced techniques. So this is, very beneficial. Again, if you're simply looking at it for how to understand MapReduce, the VMs and demonstrations out there for single node are absolutely perfect for those. These are more for a general understanding of larger operations, how clusters work. You kind of get more hands-on with it from a more holistic and well-rounded sense. So hopefully this helps everyone understand little bit more about Hadoop, and I hope you found this little broadcast useful. All right, take care.